We're going to look at a special kind of probability to do with probability trees. So Bayes' theorem is very closely related to the binomial distribution. So if you have a tree diagram which has a probability of A, which is 0.4, and probability of B is 0.6, then this mouth must always be a total of 100% or 10. Then you have a probability of D coming from A. This is 0. Maybe 0.1. Then you are also given the probability of D coming from where? B. This is 0. Maybe 0.4. So in the previous session, we're discussing when you multiply probability of A and probability of D given A. This one give us the intersection. Probability of A and probability of D given A. As long as the bottom is a multiplicand, what we're going to get is probability of D intersection A. So what are we applying? 0.
Is the pen? Not a pen.
Times 0.1.
Put for me water before you go. My son.
Please mute yourselves as you join. We are getting 0.04. How about if we multiply the probability of B times the probability of D given A, D given B? What are we going to get as a probability here? What intersection are we getting?
So it's 0.6 times 0.04.
No, not the answer, but the narration. It will be the intersection of what?
Oh, okay. So it should be intersection of D.
So intersection of D intersection what?
B.
D intersection B. What do we get? 0.6 times 0.4.
0.4.
What do we get? 0.04. So we're just learning how to do tree diagrams. Okay, so if you are given a posterior probability, this is called a prior probability, the original probability. You should always add up to what? 1. If they say probability of A is 40% and the remainder is the probability of B, so the remainder is 60%. And we're told that a sample is selected from A and it's found to be defective at 10%. So D coming from A is 10%. And the sample that is defective is coming from B. You write D given B 4%. So what is the probability of A intersection D? So under Bayes' theorem, first we need to know that if a given probability of A given B, you expand this to B, probability of B comes down. Then on top, we're going to intersect probability of A intersection B, such that if we're going to cross multiply these two, our intersection of A intersection B will be when we multiply probability of what? A given B multiplied by the probability of B. So I gave you a simple memory task to say whenever the base is multiplied, these are the same, it becomes an intersection. So A given B multiplied by probability of A. This one cannot be what? Intersection, because these two are not the same. So in short, following up this, D given A times A becomes the intersection. D given B times B becomes the intersection. We multiply these two. Then when we are adding these two, the probability of D intersection A plus the probability of D intersection B to get the common letter. This is called theorem 2. So probability of D intersection A plus the probability of D intersection B will be the probability of the common letter, which is probability of D. So in this case, our probability of D intersection A is 0.4, and the probability of D intersection B is 0.24. So 0.04 plus 0.024. What do we get when we add these two? What do we get? 0.064.
64.
Then now they'll ask you to find the opposite of any of them. A given D is like the reciprocal. It's called a posterior. So how do we expand A given D? Can somebody assist? How do we expand A given D?
Probability of A intersection D, right? Over probability of D.
So what do we get? What's the probability of A given D? What do we get there?
Zero point zero four.
Here, 0.04 divided by what?
0.064.
What do we get?
I don't have a calculator with me right now.
Somebody with a calculator?
Zero 0.625.
0.625, okay. Then the other one, try to calculate it. The other one.
Probability to expand it.
Yes, how do we expand it?
Probability of B intersection D over probability D. Right. No.
So this is, I agree. This was 0.625. Then here, probability.
Pode com paper. Bring it. Oh. Ah, gente, tem que ver muito.
Getting
Combo provavelmente possível.
what are we getting?
Zero point zero two four.
Okay, on top we're going to have 0.024. Okay, then
divided by 0.064.
Okay. So 0.024 divided by 0.064. What are you going to get?
0.375.
0.375. All right. Now, how does it come in an exam? This is how the question comes in an exam. So, two machines are producing the same item. Last week, machine A produced 40% of the total output, and machine B the remainder. So what is probability of A? Machine A, 40%, so put 0.4. What is the remainder for machine B?
10%.
Pardon?
0.6.
60%. Okay. Then we are told on average, 10%. Whenever you say on average, or if it becomes a condition probability, on average, 10% of the items produced by machine A were defective. So items defective coming from where? A. What was the percentage?
10%.
Which is 0.10. And 4% of the items produced by machine B were defective. So you say defective coming from where? B. What was the percentage? 4%. 0.04. So question number 1. What proportion of last week's entire production was defective? So now this is what we're doing. The tree diagram. Probability of A, 0.4. Probability of B, 0. What? 0.6. Then defective coming from A, 0. What?
10.
Then defective coming from B was what?
0.04.
0.4. Good. Does this seem familiar from what we're just doing?
Yes.
Yes.
So when we apply probability of A times D given A, it will give you the probability of what? D intersection what? A. So it is defective and it was coming from A, 0. What? 0.04. Then you apply B times D given B. It will give you probability of what? D intersection B. This will be 0.024. So now they're asking you what is the total of those defective. Only 4% were defective that were coming from A, and only 2.4% were defective that is coming from B. But the total defectives are, you add the defective from A and the defective from B to get the defective in general. So probability of the defectives are coming from intersecting, adding the intersection defective coming from A and defective and the way from B. So this is what we did here, 0.04 plus 0.024. So what we get here, 0.064. Is that any question at this moment? Question? Yes.
I joined late, so I don't know what I've missed.
Is if you join late and you drag the class behind, it becomes a problem. And I'll start redoing everything. So
Okay, will you send the recording?
yeah, I'll send the recording. From what I've explained,
Okay.
please, any questions? Okay, I will. This question is there in the pamphlet. For those of you who have the pamphlet, it's on page 9. I want us to look at another question. So the second part. So we've now calculated only the first part, which says what proportion of last week's entire production was defective. Then the next part, they'll just ask you if an item selected at random from the combined output of last week is found to be defective, what is the probability it came from A? So they are just asking you to find the posterior, the opposite. So what they're asking you to find is a posterior, which is the opposite. So they're asking you to find A given D, not D given A. So what we do, probability of A given D. So we're going to have what? Probability of A intersection D over the probability of D. So A intersection D was 0.04 and the probability of D was 0.064. So 0.04 over 0.064, which gives you 0.625. That is how that question was supposed to be done. So we go to another question just from the pamphlet. They'll ask you a question like this: is it possible for events A and B to be defined with the following probabilities? Probability of A is given by this, probability of B is given by this, and A given B is given by that. So now, let's look at this question and see whether it's possible to have the following probabilities. So, is it possible to have the probability of A and probability of B as 0.8 and A given? So the first thing is you need to understand the axiom that we had. Remember, we said A given B, when you multiply times what? Times probability of B, what does it give you?
A intersection.
A intersection B. So A given B is 0.2. And the probability of B is 0.8. When you multiply 0.2 times 0.8, we're going to get what? 0.16. So A union B, what's the formula for A union B?
Probability of plus probability of B minus probability A intersection B.
So for a sample space to exist, the union set must not exceed 1. So we want to test whether this sample space exists. So probability of A is 0.5. Probability of B is 0.8. The intersection we just calculated as 0.16. Give me the answer. If it's above 1, then this is not possible. The sample space does not exist.
I think it's exceeding 1.
What are you getting?
1.14.
1.14. So according to our solutions here, we're having 1.14, which is more than 1. So we should never have a probability more than what? 1. So our conclusion is that that sample space does not what? Does not exist. Okay. So that question is not asking you to find the answers, it's asking you to appreciate the what? The formulas. Then the next one here, we're given probability of A, probability of A given B, probability of A intersection B, and probability of A union B. So we want to see whether it's consistent here. So probability of A union B should be equal to what?
1.1.
1.14. A union B is probability of A plus probability of B minus the intersection of A and B. So what's the probability of A? 0.5. What's the probability of B?
0.8.
We don't have, right? What's the intersection?
What of that one? The 0.8.
There's a different question here, it's part B. Probability of A is 0.5. Okay. Probability of A intersection B is 0.3. The union set is what? 0.6. So let's find the probability of B. How do we find the probability of B? 0.6 minus 0.5. And this one, when it goes inside, to add 0.3. So we give us a probability of what? B. So this one will subtract, this one will go and add. This is what are we getting?
0.4.
0.4. So we're not done yet. We want to see whether it's consistent. So this A given B, if I multiply it by B, it should give us what?
A intersection B.
A intersection B. So what is our A given B? 0.7. What is the probability of B? We just found a 0.4. It should give us the intersection that we have found. What was our intersection that was given? 0.3. So here, when you apply these two, you get 0.28. Is it the same as 0.3?
No.
So what do we say? It is not what? It is not consistent. We say it is not consistent. Okay. Let me go to something simpler. Let me go to something a little bit simpler from the tests. I know people ability gives us a lot of help. So if I only go for the easy questions, it's like baby sitting you. So suppose we are told that UPND, those who voted for UPND are 70%. And those who voted for PF are 30%. Of those who voted for UPND, 20% are in favor of the free education policy. And those who voted for PF those that are in favor are 10%. Question number 1. Find the total number of those that are in favor of free education. What are those that are in favor of free education. Then part B, of those that are in favor, how many came from? I find the probability that the one who was in favor came from PF. So the same thing we're doing, the tree diagram. Probability for UPND is what? 70%, 0.7. Probability for PF was 30%, so 0.3. For those in favor coming from UPND, so favor coming from UPND is 20%, so 0.2. Those in favor coming from PF, 10%, so 0.10.
Mr. Collins, I have a question. So the way you've written UPND given favor 20% and then favor given UPND is just the same thing?
This is wrong. It's not the same thing. It's supposed to be favor coming from UPND. Thank you for noting that. This is favor coming from PF. You need to be very careful with the notation. So the down part for you to remember, you should say it's coming from there. So if this one is coming from there, this one is coming from there, it'll be easy for you to remember. So when we apply this one by that one, we're finding the probability of what? Favor intersection UPND. What are we getting here? 0.14. When we apply PF and this one here, we're going to have favor intersection PF. This is 0.03. Okay. So when we add these two, we're going to get 0.17. What is the total narration going to be? It's a probability of what? F, because the common letter here there's F and here there's F. So whenever we add these two using theorem 2, you get the common letter which is in favor. Then the next question to ask is, suppose somebody was picked and they were found to be in favor of the education policy. What's the chance that they came from PF? So they're asking you to find the reciprocal for the opposite of this. In short, they're asking you to find PF given what? Favor. So here to be PF intersection favor over probability of what? Favor. So PF intersection favor, it is 0.03. The total of those that were in favor was 0.17. What is the total final answer? What was the total final answer?
It's 0.1765.
Okay. 0.1765. So those ones are they that way in favor. They were coming from PF. Now I want you to think with me the test that came for the part-time answer. We're given this question here. Suppose the director of a certain company proposes a certain allowance for its employees. However, in order for this allowance to be in effect, management of a company has to agree. Assume that 40% of management are in favor of the allowance. Develop a probability distribution for the number of managers out of a sample of 2 who would be in favor of the allowance. use F for favorable and F complement for the unfavorable. So this was carrying 5 marks. We did part A yesterday. And now doing part B. The time you're writing the test, you should be familiar with all the questions from the what? From the previous tests, at least. So what are we told in that question? What are we told in that question? Yes, you were given a key to use. Suppose the director of a certain company proposes a certain allowance for its employees. However, in order for this allowance to be in effect, the management of the company has to agree, assume that 40% of management are in favor. So F is for favor. So favor will be what? 40%, so 0.4. Meaning those that are not in favor, what's the percentage? Those that are not in favor, what's the
0.6.
percentage?
0.6.
Okay. Develop a probability distribution for the number of managers out of a sample of 2. So N is what?
N is 2.
N is 2. So there's what is called probability distribution function. So in this probability distribution function, you need to basically understand that we're using a binomial distribution here, first of all, to calculate the probability of each of them. And favorable is 40%, and unfavorable is 60%, and the sample size is 2. So we are taught firstly that we need to come up with the probability distribution function. Firstly, we need to use a binomial distribution to find out the chances that there will be no one in favor, one person in favor, and 2 persons in favor. When I was teaching you binomial distribution, I told you that binomial distribution is given by n combination what? X, who remembers? Times p to the power x, and here q, n minus what? X. So we're going to start probability x is equal to 0. So you're going to have 2 combination 0 times f, or this could be our probability 0.4. And those that are not in favor, 0.6. So that comes here, and we'll put a 2 there. So we're going to find for each of them. So this is where it's coming from. For 0, 0 combination 2, the 0 comes there, and the 2 comes there. So we get 0.36. One manager is in favor, so 2 combination 1. 1 comes there, the difference comes there. So we get 0.48. And 2 managers are in favor, we do 2 combination 2. The 2 comes there, the difference comes here. So the total probability is 1. So to come up with the distribution function, so probability that 0 manager is in favor, the probability was 0.36. So you can draw a line which reaches 0.36. Probability that 1 manager is in favor is 0.48. 1, you put it in 0.48. The probability that 2 managers will be in favor was 0.16. Put a line there, 0.16. This is what was supposed to be done for this question. It was a little bit tricky, so you need to understand what we use. So here, develop a probability distribution for the number of managers out of a sample of 2. A And similar questions can come in terms of what? Coins. A fair coin is tossed. So if I told that a coin is tossed twice, a fair coin is tossed twice. Fair coin is tossed 3
Mr.
times.
Colin,
Yes, please.
just to take you back a bit, I wanted to find out, so for a question like this where it says out of the sample of 2 managers, how do you then know that you're supposed to include the probability of 0 as well?
Probability always starts
Oh.
from 0 because there's a chance that there's no manager who will be in favor. So you can't start from, all probability should start
So
from
you
0.
can't, it would be wrong to start from just for the
Yes.
for 2 combination 1 and 2 combination.
Yes, it would be wrong to start from there. All those
Oh,
probabilities. Make sure there's a chance that you have 0. So you find for
Okay.
each one of those answers.
okay.
Yeah. Any other questions? Any other questions? Okay, so we go to another probability, which was exciting on the random variables. In this one, most of the people performed well. Question number C. A company has 4 locations at which customers were surveyed for their satisfaction. Below are the listings for the average ratings of each of the 4 locations. We are simply asked to find the average. 3 marks, the average ratings. So we're going to call this column X, and this column F. So to calculate the average, what we simply do is to multiply those two for this X and F. So just multiply these 2 columns. This one times that one, we get this. 8.5 times 86, we get that. 6.6 times 68, we get that. 7.4 times 90, we get that. So this is summation of the frequency. This is summation of the fx. To get the mean, the formula is simply summation of the fx over summation of f. So we simply divide this answer there, divided by this answer. You get 7.64. I repeat, question you're given is also in the tutorial sheet. We're given 4 locations. People became confused. They didn't know what to do. You're being asked that there are 4 locations and the average ratings are given in the number of customers. The number of customers is the frequency. The average rating is the midpoint of the X. So you simply multiply each of these ones here to get the total. Then you sum up the sum of the frequency. Then when you do that, when you sum up this frequency, you're going to get 758.4 over 361. So this is how your colleagues answered this. Now your test is porous. Ideally, with confidence. I do not want, I know people will start calling me. I would want to give my phone off on that day. Because if all of you call me and all of you get 100%, I need you to try and understand this, okay? Because this test will be very easy. Just your own confusion that will betray you. His tests are usually very easy, and they're the ones that he replicates in the exam. All those questions come from a particular textbook, which I already shared. Those who are paid up, I've already said that textbook. So this question is simply supposed to multiply this by that to get this by that to get that, this by that. Then you total this by, and you divide by what? this in there. So it repeats questions. Apapa tanga waturo quib kisha memorize this with terrible exactness. Okay. So this is how we're finding the average. Any questions on this one? I want to clear my conscience because don't say I didn't cover. I've covered all the assignment questions. I'm covering all the test questions, and I'm also going to be available for all questions possible, even the questions that you feel you're underrating. We're given a list. Surely, this question, people. I don't want to say much. As you're writing these papers, as much as possible, my part with you guys, I feel happy when you clear it. The school makes money when you repeat it. Please, for the first time, I want you to have 100%, not 99% or 98% pass. The mistakes you make in the exams are your own. Okay. You need to pray for certain demons to come out, because these things that I'm talking about here, you become too fast. Sometimes you need to take time to understanding. I've explained the box whisker diagram several times. All right, so we're given the list of 11 children. Come up with the box whisker diagram. Fortunately, he already rearranged this for you. Already rearranged. So what do we need? We need to come up with a box whisker diagram. So there are 4 things that you need for a box whisker diagram. Okay. So I need you now to tell me what are the 4 things that I said that you need for a box whisker diagram. Number 1. Good. X mean.
X max,
X max.
Q1, Q2, and Q3.
1, 2, Q3. Hello, I told you that I like this lady. She puts in an effort in her work. Okay. So what does our X mean? X max, X Q1. So X mean stands for the what? The minimum value, which is what?
20.
20. X max, the maximum value, which is what?
92.
And Q1 is a quarter of what? N plus 1.
Plus 1.
So the 11. So N plus 1 is what? 12.
12.
Quarter of 12 is the third number. So what is the third number? 1, 2, 3.
29.
And Q2 is half of N plus 1. N plus 1 is 12. Half of 12 is the 6th number. Which is the 6th number? 3, 4, 5, 6.
6.
Q2, which is what? 56. And our third quarter is 3/4 of what? N plus 1.
N plus 1.
Which is what? 9. 6, 7, 8, 9. So this is Q3. Which is what? 70. The difference between these two, who can tell me? Solar, the difference between the quarter 3 minus quarter 1, what is it called?
Interquarter range.
Interquarter range. So to subtract 70 minus 29, what do we get?
41.
1. Is that so?
Yeah.
Then to get the correction term, you multiply the correction term times 1, the interquarter range times 1.5. What do you get?
61.5.
61.5. In fact, even before we go there, you can only do this if you're asked to identify the outliers. So already, box whisker diagram is already even showing there. Okay, you can be kind enough to show your number line if you want. Or if you don't want to, the smallest number here was what? 20. The highest number is what? 92. The Q1 is what?
29.
Q2,
56.
6, and Q3.
70.
This is your box whisker diagram. Then if you're asked to identify the outlier, you multiply the interquartile range times 1.5 to get 61.5. From this, subtract 61.5 less 61.5. To this, you add 61.5. What are you getting here on the lower bound? Negative what? And 1 minus 61.5 and 70 plus 61.5. Here is 130, 1.5. That's the upper limit. You're going to get what? You got 41.1. You got 41.5. The lower limit. So there's no outlier because all these numbers are sandwiched between the upper and the lower limit. So there's no outlier in this case. There's no outlier. Sula, is this clear?
Yes, it's making sense. It is actually. Thank you.
So now the other question. Question number number 1. Okay. The data has been given as follows. Calculate the first quarter, second quarter, and the third quarter. 3 marks here. Quickly, they are already rearranged here. How do we find the first quarter? So what they're trying to appreciate here is understanding how to round off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the first quarter is a quarter of 10 plus 1. What is a quarter of 11?
2.7.
Q1 is what?
2.75.
2.75. So you round off to the nearest whole number, which is what? 3. So the third number, 1, 2, 3. So what is our Q1? 87.
87.
Q2 is what? A quarter of a half of n plus 1. Half of
A
11
half.
is 5.5.
0.5.
Sula, 5.5 means what? Chuele, 5.5 means what?
You add the two, the fifth and the sixth, and divide by 2.
The number which is appearing there and the next. If there are 6, the 16th and the next. If there are 19, the 19th and the next, divide by 2. So the 5th and the 16th divided by 2. So 1, 2, 3, 4, 5, and 6. So we add these 2, divide by 2. What are we getting?
98.
98.
So we get 98. Then the third quarter is 3/4 of
It's 8.25.
8.25. So 8.25, what does it mean? The 8. The 8.
The eighth value
Which one's the 8th number?
as position.
1, 2, 3, 4, 5, 6, 7, 8. So this is 109.
109.
109.
9.
If equals and finish. Yes, Gloria.
Hi, just for clarity, on the second quartile, if you get 5.75 or 5.8, what do you do? Just to be clear.
Who can answer that? What do you do when you have 5.75 or 5.25? What do you do?
For 5.5, you get the number that's beginning and the next number. So in 5.5, we get the 5th and the 6th. For 2.525,
So for a number less than what? 5, you round off to the nearest number, which is 2. When numbers that are more than 5, you round off to the nearest number, which is 3. But exactly 5, you add the second and the third, you divide by what? 2. Is that clear?
Yes, thank you.
Right. Any other questions? Okay. So we go to the distance. The distance what? The distance test. Okay. Distance test. So here all the questions have been. Oh, there's one question that I have not looked at. This one here. And you go to financial accounting. So with that being said, unless there are any questions, I will proceed. We're given a question to say the following table shows the relative executive salary in a particular organization. So if events A up to F, the average salary and the relative salary. So under 60,000, between 60 and 70, 70, 80, 80, 90, 90, 100, and above 100. And the relative frequencies are as follows. Question number 1, determine the probability that an executive has a salary more than 70, more than or equal to 70, but less than 100. So more than 70, which one is it? But less than 100. More than or equal to 70. So starting from 70, right? Starting from 70, but less than 100. So to under 100. So we're adding these probabilities here. So 0.28 plus 0.15 plus 0.23. So this is what you're supposed to do. So more than 70 but less than 100. So we are simply adding probability of C, D, and E. C, D, and E. So C, D, and E. We add these two and we get our answer as what? 0.66. Is that clear? Then here we are told determine the probability that a randomly selected executive has a salary of either less than 60 or greater than or equal to 90. Or I've already mentioned means union or addition. We are told that less than 60. So to allow less than 60, which one is less than 60? Under 60. Salary less than 60 is what? A. So less than 60, we're talking about what? A. That is less than 60. O. Greater than 90. So greater than 90, just from here, 90 paper more. This is greater than 90. This is also greater than 90. So greater than 90 is what? E and F. So this is where E and F comes in. So you're just adding these ones here. Start looking at these other quadrants. Below 60 or above 90. So Chisung, English is a prerequisite in this course. So if you do not hear English, you need tutorials firstly in English, then that's when you get to QM. So this is how this question is supposed to be answered. Then finally asked, are these events A through F mutually exclusive? So events are mutually exclusive if and only if they don't occur at the same time. So they are mutually exclusive because A through F cannot happen at the same time. So no event can occur at the same time. So you cannot have event being at a salary of less than 100 or and being at the 67 at the same time. So they don't intersect. These ones are mutually exclusive. All of them. You can't be in two salary grades, in short, even on a practical perspective. So they are mutually exclusive. A through to F are all mutually exclusive. Mutually exclusive means to be not, they have nothing in common, to have no intersecting point. Is that okay? All right. For those who missed yesterday's class, maybe let me do question number 2A. Is that fine? So that I'm done with this. Tomorrow I'll look at the other part-time tests. In the weekend, I'll look
Yes.
at the tutorials. All right. Are we understanding? Some things are just stuff. There's nothing I can do about them, right? Some things are just stuff. There's nothing I can do about them. These are theories of dead men. Those who brought them died a long time ago. You just need to know them. All right. So suppose that 40% of the students entering a certain university do not complete their degree program. What's the probability that out of 6 randomly selected students, more than half get their degrees? The key thing is a contrast here. Here is getting their degree, here do not get. So we can say probability of getting a degree is what? 60%. Because the probability of not getting a degree is 40%. That's what has been given. Then we are told that out of 6, our n is what? 6. What's the probability that more than half? So probability that x is greater than what? Half of, what is half of 6? What is half of 6?
3.
So half is 3. So more than 3, we're looking at the probability of what? 4 plus probability of what? 5 plus probability of what? 6. So what is the probability of 4? This is a binomial distribution. So we know this is 6 combination 4. Our P is 60%, meaning the remainder is 40%. You put 4, you put 2, get the answer. Probability of what? 5 is 5 combination what? 6 combination 5. 60% is here, and 40% is here. Kalonji, what comes here?
5.
What comes here? Remainder. Great. And finally, 6 combination 6. Okay, Sydney, what comes on the 5, on the 6 here? And what comes on the
6. 6, then 0.
and 0 here? Okay, so I taught you how to find the combinations X, Y, Z. You total them up. This is a probability of more than half get their degrees. All right. So any questions?